quick polymorphism demonstration. As you know, polymorphism is the ability of one object to be interpreted or used as its base type. So what does this mean? This means that we can have many different objects that we can assign to a variable of the same type. Let me show you. We start with a couple of classes. We will use a very simple example here where we have an animal class. This will be our base class. Then we will make a dog class and a cat class. Very simple. And note that both the dog and the cat class inherit animal, meaning that whatever animal can do, they can also do. Next thing we will do is create just a very simple function, which will be a virtual function, because we want to be able to override it in the subclasses. And we will just call this getName. It will return a string. And for the animal class, we will just say return unknown animal. And I'm just going to copy this over to the other ones. Here in the subclass, we do not use virtual, but rather override. We want to override the base class function. The doggo will return doggo, and copy this one, and I will put this, I will say this is a house tiger. That's the cat. Okay, so we have our class structure. And if virtual and override and these colon and stuff like that is confusing to you, or if you don't know what these mean, please go back and read up on the inheritance part or watch the inheritance video. And so moving on, I'm now going to use these classes to demonstrate polymorphism. So what does that mean? That means I make an animal class, an animal variable, sorry. I'm just going to call this my animal, and then I'm going to go and do a dog, my dog variable. This will be a new dog. I'll make a cat, my cat equals a new cat. So the animal variable will point to an animal, which I have not created. Then there is this my dog and my cat variables. They do point to an existing dog and cat instance. So basically these two variables, they do have some data. This one does not. So what I do now is the following. I'm simply going to print out to the console the result of this getName function. So I'm just going to first of all print out the my dog and the my cat getName, and we will see, as we know from just the basic inheritance properties, that I should see the words doggo and then house tiger printed out to the console, right? Very simple. Oh, I made a mistake. I'm printing the name of the variable or the type of the variable instead of the getName function. We're doing it live, folks. So now I do see the doggo and the house tiger. Okay, good. Next thing that I want to do is the following. I want to assign these values to my animal. So I'm going to say that my animal equals my dog, and then I'm going to print out my animal dot get name. Okay. Then I will do the same with cat. So my animal equals my cat, and I print out the name. Notice, very important here, in line 11, I am printing out the my animal dot get name. Not my dog or my cat, but the animal directly. Okay, so if I run this, we see once again doggo and house tiger. And this is the effects of polymorphism. What it really means is that I am able to refer to both the dog and the cat and use their unique behaviors simply by referring to an animal. This means that I can declare one variable, and as long as all the other objects are of a subtype of this variable, so as long as I have dogs and cats and maybe other animals, I can always assign them to this animal variable, and whenever I use something that is contained in this animal variable, it will actually use the overridden method from these subclasses. So if I would have however many other subclasses of animal, like tiger, elephant, giraffe, eagle, whatever it is, and I would call the get name through the animal, so I would say my animal.getName, it would find the get name of the subclass instead of using the actual animal get name. Okay, I can also do it like this, just for the sake of completion. I could also say my animal equals new dog, right? Or my animal equals new cat. And these will produce the same result. Notice again that I'm using my animal.getName. So I'm now not assigning any existing variables to this my animal variable. I am basically creating a new dog, a new instance of the dog type, and directly assigning it to the animal variable. If I run this again, we will see I get again the same result, doggo and house tiger. So this is exactly the same behavior as doing this assignment of the different variables. Okay, so this is the basics of polymorphism. Now, important to note here is that polymorphism is one-directional. What does that mean? That means that if I have my class hierarchy or class tree or inheritance tree, I've got an animal class and I've got a dog and a cat class, and they inherit or are subclasses of animal, right? Now, polymorphism only works one way up this tree, basically. I can take a dog and call it an animal, and I can take a cat and call it an animal. But I cannot do the opposite. I cannot take an animal and call it a cat. This does not work. I also cannot take a dog and call it a cat, or vice versa. This also does not work. I can show you that this is true by doing a very simple thing. I can say my dog equals my animal. This will not work. As you see, it says cannot implicitly convert type animal to dog. Okay. And same thing with the cat. And I can also not say my cat equals my dog. Again, the same error, cannot implicitly convert dog to cat. Now, you might have noticed that there is a small difference in these two error messages. This one just says that you cannot implicitly convert, right? But this one said an explicit conversion exists, and then it asks you if you're missing a cast. So this is part 2 of this polymorphism video, casting. It is still true that we cannot go down the chain, basically, down the tree. We can still go up only. But there is a way of going down. So there is a way in which I can assign an animal to a cat or an animal to a dog. And this is casting. Let's see what casting really does. The first thing that we have to do is go to this animal that we are trying to store inside of the dog function variable, and we need to cast it to a dog. So basically, we are going to try to convert this animal variable to a dog. And we do this like that. We use these parentheses. Inside of the parentheses, we just write the type. We do not write a variable name or anything like that, but just directly the type. Now, what this will do is the computer will look at the data inside of this myAnimal variable and will try to convert it into a dog instance, right? It will try to read it as if it were a dog. Now, very important. Right now, on line 22, what is stored in this myAnimal variable is not a dog. It is indeed a cat. So, I will run this program and we will see what happens. Invalid cast exception. Invalid cast. Unable to cast object of type cat to type dog. So, this gives us two very important pieces of information. This is a very, very useful error. First thing that we can gather from this is that if this variable does not contain an instance of this type, we will get this error and we are not able to cast it. So the first thing. Second thing is that we cannot cast from cat to dog. So this relationship here is still impossible. We cannot go from cat to dog. We can go from animal to cat and from animal to dog. So we can do this. We can go from here to there by casting, and from here to there by casting. Oop. Right? But we still cannot go from dog to cat. So if my animal variable contains a cat, I cannot cast it to a dog because it is a cat. It literally, there is a cat in this variable. So we cannot cast it. We can only cast the animal variable to a dog if what's inside of this animal variable is really a dog. And this is really important. Polymorphism does not mean that I can do whatever I want and convert any type to any other type, but rather that I can abstract how high or low in this inheritance tree I really am. So I don't really need to know if what the object that I have is a subclass or a supraclass of the other object. I just need to know that they are somehow directly related, meaning one is a parent or a child of the other, so one is above or under in the hierarchy. As long as I know that, I can work with these objects. If they are going to the sides of the tree, so meaning not direct parents or children, or also grandparents, right? So this tree could be bigger. It does not necessarily have to only have two levels. So you could have also different types of dogs and different types of cats. As long as you go up and down, there's no problem. The moment you want to go to the side, you get problems. So this is the very basic. And just to make it clear here, I can also go from dog or from whatever is in here, I can go up. From whatever is in here, I can go up. And same here, this is not a problem. I can go from cat to this, I can cast. I can also cast directly from animal, so I could also do this. I can cast directly from animal to this subclass or to a subclass. Doesn't matter how many layers deep it is. You can always cast when you go down, and going up, so going up the tree, you can always implicitly convert this object. So you don't need to cast. The computer just knows, just does it automatically. There's no problem with that. And I still cannot do this. This does not work. This does not work. This does not work. This is all impossible, okay, in any direction. Doesn't matter what direction you're going to. Okay, so that's casting. We have this exception here. I will leave this exception as it is. I'm going to say here that my cat equals cat my animal, and we will see that now this will work because there I do have a cat, right? So then I can convert this to a cat. We'll see, we will still have the same exception, but only on this line, so exactly on the same line, on the dog. The cat was successfully casted, and I'm going to now comment this out, and I will say invalid cast exception. Now, what if I don't want to crash my program if this fails? Maybe I just want to check if this is possible, because maybe I don't know which actual object is there. Maybe I want to check, hey, is there a dog there? If it is, then cast it. Is there not a dog, like a cat or something else, then don't cast it. Like, okay, just skip to the next one, maybe try to cast it at something else, right? There is a way of doing this, and there are actually two ways. I will show you both. The first one is we can just simply check whether it is a dog or not. How do I do this? Very simple. I go and check. So I will do an if statement here. If my animal is dog, then I will cast, right? So I will say my dog equals dog, my animal. So this will check if the actual type, the real type of the data that my animal points to is of type dog. We know that the variable my animal is not of type dog. The actual variable is not, it's of type animal. But this actually checks the data, and it sort of tries to convert it. And if it is successful, then this returns true. If it's not successful, it returns false. And if it returns false, this never runs, so we do not get the exception, right? So this is one way of getting around it. The other way of getting around it is by doing what I would call a safe cast. What is a safe cast? It's this. We say my dog equals my animal as dog. Okay, so this is almost the same as casting, but the difference is if the value inside of my animal, if the actual data is not a dog, then this does not do anything. It just returns null. It returns a null pointer. Let's check this out. I will set a breakpoint here. And press F11. We skip this if statement, right? Because this was false. I can hover over here and you see that it's false. And now here, my dog, as we see right now, it does have a dog instance. When I run this line, well, we do not see it. Let me just have a line here so that we can see what the value of my dog is going to be, and it's going to be null. So if this my animal data is not a dog, then the value we get here is null. And obviously, if it is a dog, or in this case, if it is a cat, because it is a cat, then it will just cast it, basically, right? So I go there, this would be null, And this one is not null. This is a cat because it just takes whatever is in the my animal data and casts it to cat and places it there. Okay, that is it for polymorphism. It's a very simple concept, but in practice, it gets sometimes a bit nasty to unravel all this stuff. If it gets nasty and it gets confusing, just remember this tree. You can go up implicitly, so you don't need to cast anything. If you want to go down, you need to cast. And if you want to cast, you can do the safe casting, or you can do the you can use the is keyword to check whether it is possible to cast. And you can never cast to the sides of the tree. That's it. See you next time.